Welcome to the third video of AP Statistics in our playlist. According to previous videos, we already know how to draw stem plots, we know how to describe the distribution, and we know the different types of shapes from the distribution. So in this video, we're gonna continue learn SOCS and dot plots and box plots. Those are the two graphs that we'll introduce in this lesson. They're quite different with the stem plots, but they're also super fun and contains a lot of details that will help you learn more in depth of stats. So finishing up our notes for SOCS, we haven't talked about the outliers yet. We already talked about the shape, which is the first letter S in here, but we haven't talked the O in here. So what is outlier? Well, the definition for outlier is a data value that more than 1.5 IQR away from Q1 and Q3. Well, what is IQR? IQR is the interquartile range, and the Q1 and Q3, well, what are those? So Q1 is the median of the observation located to the left of the median in the order list, and the Q3 is the median of the observation located to the right of the median in the order list. So you may completely lost in here, I just threw a bunch of definitions to you and those terminologies probably does not make any sense, but that's okay. We will explore more through the examples. So just remember the definition for outlier, and let's take a closer look for the real world example. So the formula for outliers, which you must know from memory on the AP exam, is, well, Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. Let me see. Sorry about the messy notes in here. The format is just went completely wrong in here, but just jot down what I said, like Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. So those you may, some teachers maybe also call them the fence method. Those are the two bounds that if the outlier exceed or below the bounds, then it will be considered an outlier. So if data that is below Q1 minus 1.5 times IQR, then it will be considered as an outlier. Same as a data that is above Q3 plus 1.5 times IQR, it will also be considered as an outlier. So let's take a closer look at example. So our SOCS all together now describing a box plot in one short paragraph. So take a look at we know from the previous lessons we drew the stem plots for the ACT exam, right? So in here we're gonna change it to a box plot, which requires basically 4 components. It divides these 4 parts into 25% each. You may see that it's kind of strange, those sometimes those are lines and those are boxes here, and they also seem to have different length. How could they be the same percent? Well, it doesn't matter that you see it visually have a different or same length or not. Each part should have 25% always, but they all correspond to different values. So in here, it means the minimum value from the frequency table or any of the data that you collected. This is the smallest value in here. And in here, this is usually the Q1 in here. So this is what I talked about previously in here, which I haven't wrote down. I think I definitely wrote down previously, but it just disappeared for some unknown reason, so sorry. So Q1 in here, Q1, remember that is the median of the left of the median. So median will be here. So median is typically the middle length, or sometimes it's not directly in the middle, but it's always line that is in the box. And this is Q1, this will be Q3. So you can see that if we divide median of the whole like graph in here, then each part, like right part and left part, will be 50% each. But Q1 and Q3 also divide those 50% like into 25% each. So total there's 4 parts and each part is 25%, and this is the maximum value. And we don't have outliers in this case, but sometimes if you met an outlier, it will usually be a dot that is far away from the whole graph. Like it either be like here or it will be like here. Yeah, so I can't really change anything from here. But recall from what we learned previously, SOCS, shape, outlier, center, and spread. So in here, we will introduce the five numbers memory. So it basically just the thing that I talked before is the minimum, Q1, median, Q3, and maximum. And those are the data that is from the previous example, the ACT scores. You can check out I think first and second videos all contains them. So if you like watch them by order, you won't have like problems with those. So let's also take a look at like different mean and standard deviations in here. So like there's like 2 pairs of them. So the first pair is the two like the 2 lines above, and like if you like imagine there's a line divides these 2 things. This is the mean, this is the standard deviation, this is also a mean, and this is also standard deviation. Well, how could there be like 2 sets of standard deviation and mean pairs? Why wouldn't just we use one? Well, it's because like stats is all about like doing the observations and like the tests and take a look at the population. Like we usually take a sample like proportion from the whole population and analyze them to predict the whole population. So like in most of the scenarios that we cannot just take all of the data from the population, that will be a census, and it takes a lot of efforts and energy, and in real life world most of the cases we cannot do it. So it's better just to use a sample. So it's typically what the reason why that we have like 2 sets of pairs for means and standard deviations. So this like kind of like a weird writing for you. This is the population mean, and this is like also a weird symbol in here, but this is the population standard deviation. And there's a X with a bar on top. This is the sample mean, and the S means this is for the sample standard deviation. So we will map those later, like in the whole course, but just jot them down and like noticing them in here. We don't have to deal a lot with them right now, but those are just good memories. Yeah. Oh, and then so how do we find the median? I forgot about this piece. Usually we use this formula. So n plus 1 divided by 2. This tells us the position of the median. Remember, this is not the real value of the median. This is the position, like where is that median value located? And this n just means the numbers of the data we collected. And range is just max minus mean. And this is the average distance from mean. This is a pretty like a huge formula in here. But we really don't have to like deal with them a lot, at least by hand. No, we use calculator for it mostly. And just know like this symbol is sigma, and this is the summation notation. This means that we use all of the individual, like we just know that this x bar right now, x bar in here, this represents the sample mean. So we use each individual mean minus the sample mean. and we use the difference to square that, and we like add all of the differences for each data in the sample with their sample mean, and we find the difference, square that, and all divided by the numbers of data minus 1, and take the square root of the whole thing, and we get the sample standard deviation in here. Again, we don't have to do this all by hand. We will mostly use the calculator, which is pretty easy in here. So this is just for a reference if you're curious. Okay, so let's move on. So interquartile range, IQR, as we talked about it previously, we can work this out on our calculator with just a little effort. So denoted by IQR. IQR is Q3 minus Q1, and this is, in our example, this is 27 minus 21, and it's equal to 6. So exploring the 5-number summary on the TI 83 or 84, useful for constructing a box plot. So whatever what calculator you have right now, either 83 or 84, I think those two are kind of like, they have very similar functions and it's pretty easy to use. But if you have like the old ones or like some others, it will be fine, I think. But the box plot, like how to use the calculator for this, I think this is pretty hard to show it, like since I am like screen recording my computer right now, I cannot really show you how to do all of the things on the calculator. But basically, like you just hit the second and y equals. So first it equals tap second and then tap y equals and tap 1, and you will turn on the plot, and like there's a plot 1 and there's on and off below, like there's 2 buttons. You have to hit the on button to make everything works. And below there's type, then there's a lot of like different graphs for you to select. Because we want to draw a box plot, we will select the I think depends on the calculator, but like we already draw the box plot one, like there's one by hand, so just select the one that is most similar with what we did. And after you draw it, then for the X list, like use L1 for it, and the frequency use L2. Yeah, and definitely you have to type all of your data, like enter all of your data to the tables first. And usually the x-axis, like all of the data on the x-axis will be in list 1, and all of the data in y-axis will be in list 2. So after you enter all of this, you just hit graph, and I think you will be able to see a box plot fully. So sorry about like cannot show you what I did on the calculator, but I think if you follow my steps, then probably no problems with it. I hope so. Yeah, so let's move on. Let's take a look at the dot plots, box plots, and the rest of SOCS. So again, like we are kind of just stick with the ACT math scores scenario, and continuing with SOCS, this time we will see the measures of center. So remember SOCS, we already did the S and O, and we are gonna do another C in here. So C in here stands for the center. So center, there's like two main parts for the center. One is the mean, and the mean the definition for it is add up n values and divide by n, and it denoted by x bar. So yeah, I'm sorry for this line, like it's kind of like unnecessary for this part, but more than 1.5 IQR away from Q1 and Q3, this is the definition for outlier, it's not for mean. So sorry about that. Yeah, and ignore all of this. This should be like in the previous couple pages, but the formatted it just completely went wrong. But yeah, again, like look at the formula right here. This is what I'm talking about for mean. So x bar is the mean. This is the summation notation. You add up all of the x sub I, and from 1 to n is the number of data you collected, and you divide it by the number of data you collected, which is pretty much like the average that we calculated. Like, but the mean is like pretty. It's also different with average, even though in real life we always use these two words as synonyms, but in stats we don't. It has to be professional. So that's the mean, and this median is the middle value. It also called the 50th percentile, which I think makes sense because median is usually the value that sits at the center of the data. If you put all of the data in one line, then the median will be the half position for the whole data. So it's really hard to see it from here, that because it covers like by all of these words. So let me get my notes in here. Yeah, so median in here, this should be the P right here. It kind of like covered by the 5 in here. So this should be the Pth percentile, denotes particular data values such that P% of the data values in the distribution lie at or below this particular data value. Okay, so this is just like a very like wordy explanation for this, but it's fine if you didn't fully understand it right here. I will explain that later. So continuing with SOCS measures of spread, we're kind of at the end of our 4 like capital letters definition. We already covered the SOC and we only left S in here. This time it stands for the spread, not the shape. So spread, there's also like some like contents include in here. Like first of all, the standard deviation. The standard deviation is our calculator will give it to us. Most of the cases we don't have to do it by hand. If you choose mean as your center, standard deviation is usually the appropriate measure of spread. So mean, just remember mean is always stick with standard deviation, and and we will talk about others later. Like IQR usually stick with range. But like it's denoted by S sub x. This is the symbol for standard deviation, and S sub x is the square root of an important number unit for called the variance. So this is what we are going to cover in the future units. This is a magical term in here called variance, which explain it in the later videos. And it measures the amount that and data value typically differs from the mean. So this is kind of like ambiguous, but think about like the mean. It's like the average value of a set of data, and the standard deviation is measures like, well, how far is individual or a specific data from the mean. So the distance, and also it gives us another like definition for it. Like, you know, the distance can never be negative, so as standard deviation. Okay. So let's keep going. Yeah, I think there should be. The others are just some of the examples in here, so we won't talk about it. Those we just ignore that. Not that important. But we will describe the shape, outlier, center, and spread. So you can see that I am repeatedly talking about the SOCS. So you kind of see that how important they are. Like they're super important, especially when you're asking to find to answer the FRQ in the AP test. They ask you to describe the distribution. You have to talk about all 4 parts of those. So a box plot, we'll move on to the box plot. So before we just all talking about the kind of the SOCS and a little bit about the box plot, but we also see how to draw a box plot both by hand and on the calculator. So just highlight again, for the box plot, that we can't say that it's unimodal or bimodal, or in quotation marks normal. Those are just some warnings in here, because from a box plot, it's not like a stem plot. From a box plot, if you can recall from our notes, right here, we cannot really see that how is the whole graph looks like, right? How is it like that, is skewed to the right, or it's skewed to the left like that, or it's just normal graph, symmetrical. We cannot tell anything from the box plot, so we cannot mention that in our description for the distribution. Okay, otherwise you will lose points. Okay, and this is our dot plot. Yeah, so dot plot is kind of easy, I hope. It's usually there's a number line at the bottom, and we usually don't draw the x-axis because it's unnecessary, but we usually put the dots for each of the numbers. So recall our ACT test scores example. The people who got 7 points, there's only 1 person, and people who got 18 points have 2, and people who have 19 points have 3. So you can see the pattern from here. So this is kind of easy peasy. And so those are just the graphs that just reinforce again from here. Symmetrical graph looks like this. You can see that left side and right side kind of have the equal amounts of data. Skew left, which means that the tail, which one has less data, well, in this case, it's on the left, so the whole graph is skewed to the left. And skew to the right, well, there's less data on the right, so the whole graph is skewed to the right. Okay, so a little bit more about this. So skew to the left, we also, okay, so there's another very important topic. If a graph is skewed to the left, then we know the mean is less than the median. If it's skewed to the right, then the mean is greater than the median. Okay, so just think about it visually. If a graph is skewed to the left, then it's gonna be here. So the mean is gonna be, well, because the median is not impacted by the amount of data in different areas, so the median will always be the 50th percent, at the 50th position of the whole data. So, but the mean, because there's more data on the on the lower bound in this position, so which means that it will lower the mean, right? Because there's gonna be less data that is in the high bound right here, so it will lower the mean, but the median does not been affected, so which will cause mean is less than the median. Same for the skew to the right situation. If you can see from the graph, more of the data is located in the high bound of the x-axis, or more of the data has been located at the low bound of the x-axis. So which means that the median will be still at the 50th position of the data, so it will be probably somewhere here, but because no, it will be somewhat here, but because more of the data is like is on the lower end, so which will which will the mean, which will like high up, like lift up the mean. Yeah, so then the mean is gonna be greater than the median. Okay, so yeah, let's take more look at those. And the skew data, we usually use median and IQR to describe those. We don't use mean and standard deviation. Mean and standard deviation is usually used to describe the symmetrical distribution. And for the skew data, we use median and IQR. And remember, those are the two types of variables that are resistant to outliers. And resistant, it just means that it's not affected by outliers. So, and like an outlier won't pull up the mean, the median, like dramatically, and it also won't like pull up the IQR dramatically, because remember, IQR is Q3 minus Q1. So Q3 and Q1 is also depends on the median. So it's kind of like a chain rule. If median does not been affected, then Q3 and Q1 will not be affected either, same as IQR. Okay, so let's move on to the stem plot here. So stem plot, remember, always include the key. So if like 1/2, you have to write equal to 12 on the side of your graph. So there's dot plots versus box plots. Dot plots, we like draw it previously. It's like that. It's a rough sketch. And a box plot is look like this. And also remember to do it on your calculator. The histogram is like, you usually let the calculator to have like 5 to 8 bars on your screen. If like on your calculator, if your calculator cannot show 5 to 8 bars fully, then there's a chance that there may be some biases occurs, or like not showing the whole picture. So make sure that your calculator showing like 5 to 8 bars fully on your screen. Yeah, so this is only 4 bars, so may not be good. And this is also another thing, like this is the categories. This is different with the histograms. This is a bar graph. And they look pretty similar, but the bar graphs have like the gap in between each bars, but the histogram don't. And like you can see that histogram, we also use it to usually measure the quantitative data, which bar graphs, we usually use it to measure the categories of the data. So in the x-axis in here, it should be categories for bar graphs, and in the histogram, the x-axis usually should be the quantitative variables in here. So do notice the difference in here. It will appear on the test, I think. Okay, so there's a little bit more. Yeah, this is just the re-highlight for the histograms. Make sure to have 5 to 8 bars showing on your calculator screen when you use your calculator to draw the histogram. And this is a bar graph. Okay, this is all we have. Thank you so much for watching, and I hope you learned something from this video. More notes and more content. Stay tuned, and thank you.